Welcome, dear listener. You've found your way to Dreams of Gravity, and we're so glad you're here. Wherever you are right now, tucked beneath a warm blanket, lying in the quiet dark of your room, or simply resting your eyes after a long and busy day, know that this is your time. This is your space. There is nothing you need to do, nowhere you need to go, and nothing you need to figure out tonight. You can simply let go. Take a slow breath in and let it out even more slowly. Feel how your body begins to soften, just a little, with every exhale. Notice the weight of your limbs, the way your shoulders drop when you stop holding them up. There is a kind of relief in that, isn't there? In remembering that you don't have to carry everything all at once. Tonight, we're going to travel together, not through any road or sky you've ever known, but through something far vaster, far older, and far more beautiful than anything our everyday world can offer. We're going to drift through the universe, through the galaxies and nebulae, the ancient stars and silent planets, the strange and patient darkness of deep space, through the greatest discoveries ever made by the people at NASA, those quiet, curious, relentless human beings who looked up at the sky and decided they needed to know what was out there. But we won't rush. Tonight, there's no rush at all. We'll take our time, like a leaf floating down a slow river, carried gently by the current without effort, without resistance. And somewhere along the way, you may find that your thoughts grow quieter, your breathing grows deeper, and the world of dreams begins to open up around you like a flower opening in slow motion. That is perfectly fine. That is exactly what this place is for. So close your eyes if you haven't already. Settle into whatever position feels most comfortable. And let's begin. Imagine, for just a moment, that you are floating, not falling, floating. There's a difference. Falling has urgency, direction, fear, but floating is something else entirely. Floating is trust. It's the feeling of being held by something invisible, something vast and gentle, like lying on the surface of a warm, still ocean with the water just barely rocking you, and the stars overhead reflected in the water below, so that you can't quite tell where the sky ends and the sea begins. That's what space feels like when you imagine it from the inside. Not cold and frightening as the movies sometimes make it seem, but infinite and soft. A great, breathing darkness that holds everything, every star, every planet, every grain of dust, every dream, within it, without preference and without judgment. Everything belongs there, including you in a way you might not expect, which we'll get to in time. NASA, the National Aeronautics and Space Administration, was born in 1958, just 1 year after the Soviet Union launched Sputnik, the first human-made object to orbit the Earth. There was urgency in those early days, a kind of electric anxiety, the feeling that humanity was suddenly, for the first time, capable of leaving its cradle. And that is precisely what we did. Slowly, carefully, with enormous courage and enormous curiosity, we began to reach outward. But what NASA eventually gave us was something no one could have fully predicted. Not just rockets and satellites, not just the technology to go to the moon and return. What NASA gave us was a new way of seeing ourselves, a new understanding of where we come from, what we are made of, and how extraordinarily, improbably lucky we are to be alive on this particular blue dot, in this particular corner of an ordinary spiral galaxy in a universe of 2 trillion other galaxies. 2 trillion. It's a number so large it loses its meaning the moment you say it. So let's not think about it as a number. Let's think about it the way you think about the ocean when you stand at the shore. Not counting the waves, not measuring the depth, just feeling the immensity of it. That soft, slightly humbling feeling when something is so much larger than you that your usual categories of big and small simply dissolve. That's the universe, and that's where we're going tonight. By the way, I wonder, where are you watching from tonight? Which city and what time of day is it for you right now? Are you somewhere with rain tapping gently on the window, or perhaps a warm and silent night with the faintest breeze? I find myself curious about the people on the other side of this voice, the different rooms, the different skies, the different hours of dark and quiet. It's a lovely thing, really, that we can share this journey from so many different corners of the world. And now, gently, let's return together to the stars. Let's begin with something that changed everything. Something that, when it was first proposed, seemed almost too strange to be true, and yet turned out to be one of the most important things NASA and humanity ever confirmed. Let's begin with the Big Bang. Not with a bang, actually. That name has always been a little misleading. The event that began the universe wasn't loud. There was no sound at all because there was no air, no medium through which sound could travel. There wasn't even space yet, not in any form we'd recognize. What there was, at the very beginning, was something almost impossible to describe. A single point, smaller than anything we can imagine, containing everything that would ever exist, at a temperature so extreme that the very laws of physics as we know them hadn't yet formed. And then, approximately 13.8 billion years ago, it expanded. Not exploded, expanded. Think of a balloon being slowly inflated, but where the balloon itself is space, and the air filling it is energy and time and the seeds of all matter. In the first fraction of a second after the beginning, the universe doubled in size millions of times over in a process called inflation. It was faster than light, which sounds impossible, except that what was expanding wasn't something moving through space, it was space itself stretching. How do we know this happened? That's where NASA comes in. One of the agency's most profound contributions to our understanding of the universe was the COBE mission, the Cosmic Background Explorer, launched in 1989. COBE was designed to look for something called the cosmic microwave background radiation, a faint afterglow of energy left over from the Big Bang, still drifting through the universe like the last warmth of a fire that burned nearly 14 billion years ago. And COBE found it. Not just found it, mapped it, created a picture of the universe when it was less than 400,000 years old. An infant universe, barely formed, already patterned with the tiny fluctuations in temperature that would eventually, over billions of years, grow into galaxies, stars, planets, and everything that has ever lived or thought or wondered about its own existence. That image, that soft, oval map of the early universe, glowing in shades of orange and blue, was awarded the Nobel Prize in Physics. It was one of the most important scientific confirmations of the 20th century. And it told us something remarkable, that the universe had a beginning, that time itself had a beginning, that before the Big Bang, the question, what was there before, may not even have a meaningful answer, because time as we understand it didn't exist yet. Breathe in, breathe out. Let that sit with you for a moment without needing to fully understand it. Some things are beautiful precisely because they live just at the edge of comprehension. Like the feeling of a dream you almost remember when you wake up. The shape of it is there, the emotion is there, but the details slip away like smoke. The beginning of the universe is a little like that. We can feel the edges of it. We can see the echoes. But the thing itself remains, in some profound and lovely way, a mystery. And mysteries are not always things to be solved. Sometimes they are simply things to be held gently in the mind, turned over slowly, like a smooth stone in the palm of your hand. The universe, in its earliest moments, was extraordinarily simple. Just energy, expanding and cooling. As it cooled, the first particles formed. Quarks and electrons and photons, the most basic building blocks of everything. Then, as temperatures dropped further, those quarks combined into protons and neutrons. And a few 100,000 years later, the first atoms formed. Mostly hydrogen, a little helium, and trace amounts of lithium. The simplest elements, the most ancient ingredients. From those three humble elements, everything else eventually came. All the carbon in your body, all the oxygen in your lungs, all the iron in your blood. None of it existed yet. The universe would need stars for that, and it would have to wait. For about 200 million years, the universe was dark. No stars, no light, just clouds of hydrogen gas slowly drifting together under the gentle but relentless pull of gravity. This period is sometimes called the Cosmic Dark Ages, and there's something quietly poetic about it. A universe waiting. A vast ocean of gas, breathing slowly in the dark, like a sleeping giant not yet aware of what it's about to become. Then, the first stars ignited. No one was there to see it. There was no one to see anything, not yet. But somewhere in the ancient dark, a cloud of hydrogen gas grew dense enough and hot enough for nuclear fusion to begin, for atoms of hydrogen to begin slamming together and fusing into helium, releasing energy in the form of light and heat. The first star, brilliant and enormous, blazed to life in the darkness, and then another, and another. The Dark Ages ended. The universe began to shine. Those first stars were very different from our sun. They were enormous, hundreds of times more massive, and they burned intensely, living fast and dying young, as the most massive stars always do. But their deaths were not quiet. When those first stars exhausted their fuel and collapsed, they exploded in supernovae. Cosmic fireworks so powerful that in the space of a few seconds they could outshine entire galaxies. And in those explosions, something extraordinary happened. The first heavy elements were forged. This is one of the most profound things science has ever discovered, and it connects you, personally, to the history of the universe. Every element heavier than hydrogen and helium, carbon, nitrogen, oxygen, iron, gold, calcium, silicon, was created inside a star or in the explosion of a star's death. These elements were scattered into space by supernova explosions, mixed into new clouds of gas and dust, and eventually incorporated into new stars and planets, including our Sun, including our Earth, including you. The calcium in your bones was forged in the heart of a dying star. The iron in your blood was scattered across the galaxy by a stellar explosion billions of years ago. You are, in the most literal and scientific sense, made of stardust. Not as a metaphor, as a fact. NASA has confirmed this through decades of observations, studying the spectra of stars, analyzing the chemical composition of nebulae, tracking the life cycle of stars from birth to death. The Hubble Space Telescope, perhaps NASA's most famous instrument, has given us images of stellar nurseries, vast glowing clouds of gas and dust where new stars are being born even now, lit from within by the young stars forming inside them. The Hubble. Let's take a moment here, because Hubble deserves a moment. It was launched in April 1990, and when the first images came back, there was heartbreak. The mirror was slightly misshapen, just 2.2 micrometers off, and the images were blurry. For NASA, it was a painful and very public failure. But then, in 1993, astronauts from the Space Shuttle Endeavour performed one of the most daring and delicate repair missions in history, spacewalking to install corrective optics, essentially giving Hubble a pair of glasses. The images that came back after that repair took the breath away. Pillars of creation. Towering columns of gas and dust in the Eagle Nebula, where new stars are being born within folds of cosmic cloud, so beautiful they look like something from a dream. The Hubble Deep Field, a single image taken by pointing the telescope at an apparently empty patch of sky for 10 consecutive days, and finding in that darkness not emptiness but thousands upon thousands of galaxies, each containing hundreds of billions of stars, each impossibly far away, each impossibly real. That image changed the way humanity understood itself. Because before Hubble, we could know intellectually that the universe was vast. But when you see those thousands of galaxies crowded into a patch of sky, no larger than a grain of sand held at arm's length, when you see the depth and density of it, something shifts. Some door in the mind opens that cannot be closed again. And it opens onto wonder. Not fear, wonder. Let your breathing slow a little more now. There's no need to hold any of this information tightly. Let it drift through you like music, like the sound of rain on glass. You don't need to memorize it or understand every detail. You're just floating through it, the way you float through a dream. Aware of the shapes and colors, the feelings and textures, but not attached to any particular corner of it. Let's drift now toward galaxies. Because galaxies are one of the universe's great poems, and NASA has spent decades learning to read them. A galaxy is, at its simplest, a gravitationally bound collection of stars, gas, dust, and something we call dark matter. A mysterious substance that doesn't emit or absorb light, but makes up roughly 27% of everything in the universe. We can't see dark matter directly. We can only infer its presence from the way it bends light and holds galaxies together. It is one of the universe's great secrets, one of the most important frontiers of modern astronomy, and it reminds us that most of reality, most of what exists, is invisible to us. Think about that for a moment. We can only see about 5% of the universe. The rest, dark matter, dark energy, and forms of existence we may not yet have the concepts to name, is beyond the reach of our eyes and our instruments. We live in a universe where the visible is the rare exception, not the rule. Like the surface of a deep ocean, bright and knowable on top, while beneath it stretch unimaginable depths of cold and dark and silence. Our own galaxy, the Milky Way, is a barred spiral galaxy, a flattened disk of stars with a central bar structure and spiral arms curving outward like the arms of a pinwheel caught in a slow turn. It is approximately 100,000 light-years across. 1 light-year is about 9.5 trillion kilometers. So 100,000 light-years is a distance so large that if you tried to write it out in ordinary kilometers, the number would stretch across this page many times over. The Sun sits about 26,000 light-years from the center of the galaxy in a region called the Orion Arm. We are, in galactic terms, rather far from the action. Out in the suburbs, you might say, orbiting the galactic center at a speed of about 230 kilometers per second. And at that speed, it takes the Sun approximately 225 million years to complete a single orbit of the Milky Way. The last time the Sun was in its current position relative to the galaxy, the first dinosaurs were just beginning to appear on Earth. At the center of the Milky Way lives something that NASA confirmed through decades of observation is one of the most dramatic objects in the universe, a supermassive black hole named Sagittarius A star, with a mass approximately 4 million times that of our Sun. Black holes. Even the name has a kind of gravity to it, doesn't it? A weight, a mystery. A black hole forms when a massive enough star collapses at the end of its life. Gravity wins. The core of the star compresses to an almost impossibly small point, a singularity, and the gravitational pull becomes so extreme that not even light can escape. The boundary around a black hole beyond which nothing can return is called the event horizon, and it is one of the universe's most profound one-way doors. But here is something that might surprise you. Black holes are not the great devourers popular imagination makes them out to be. They do not wander through space sucking up everything around them. Most of the time, a black hole simply sits there, patient and still, like an enormous weight at the bottom of a still lake. Stars and gas orbit it, just as planets orbit the Sun, unless they wander too close. And from a great distance, a black hole's gravitational effects are not so different from those of any other object with the same mass. What makes them extraordinary is what happens at that edge, the event horizon, and what lies beyond it. According to our best understanding of physics, time itself slows down near a black hole. An observer falling into one would, from the outside perspective, appear to freeze at the event horizon, growing dimmer and redder as time slows to a halt. But from the falling observer's own perspective, they would cross the event horizon in a finite and relatively unremarkable moment, and continue falling. What happens beyond the event horizon, in the singularity at the center, is something our current physics cannot describe. The equations break down. The numbers stop making sense. It is one of the great open questions. What is the nature of space-time at a singularity? What, if anything, lies beyond? In April 2019, an extraordinary milestone was reached. The Event Horizon Telescope project, a collaboration involving NASA and observatories around the world, released the first image ever taken of a black hole. Not Sagittarius A star, but a far larger black hole at the center of galaxy M87, 55 million light-years away, with a mass 6.5 billion times that of the Sun. The image showed a glowing ring of superheated gas and light, with a dark shadow at the center, the silhouette of the event horizon. It was blurry, as these things sometimes are. The technology that produced it was astonishing. A virtual telescope the size of the Earth, using coordinated observations from radio dishes across multiple continents. And the result was a small, slightly blurry orange ring. But the feeling it produced in the people who saw it was enormous, because it was real. It was actual. an actual black hole rendered in actual light for the first time in human history. Breathe in, breathe out. Let your body sink a little deeper into wherever you're resting. You don't need to hold anything tightly tonight. These ideas are here not to fill your mind, but to give it somewhere soft to rest, the way a river gives a leaf somewhere to float without effort. If you find your thoughts drifting away from the words and into the slow warmth of sleep, let them go. That is exactly right. Let's drift now through the solar system, because here is where NASA's story becomes most personal, most tangible. Here is where the rockets were built and the astronauts flew, and the rovers rolled out across alien soil and looked back at us through their cameras. Our solar system began about 4.6 billion years ago, when a cloud of gas and dust, enriched with heavy elements from ancient stellar explosions, began to collapse under its own gravity. As it collapsed, it flattened and began to spin, like a pizza dough being twirled in the air. At the center, the densest region grew hot enough to ignite nuclear fusion, and the sun was born. Around it, the remaining material clumped together through a process of gentle collisions and accumulation, forming the planets. The four inner planets, Mercury, Venus, Earth, and Mars, are rocky and relatively small. The four outer planets, Jupiter, Saturn, Uranus, and Neptune, are giants, mostly made of gas and ice, born in the colder outer reaches of the solar system, where water and other volatile compounds could condense. Earth, our home, formed about 4.5 billion years ago. It was initially a molten ball of rock, bombarded constantly by asteroids and other debris. Then, roughly 4.5 billion years ago, something extraordinary happened. A Mars-sized object collided with the young Earth at an angle, and the debris from that collision was flung into orbit and gradually coalesced into our moon. The moon we see every night, that lights the dark and pulls the tides, was born from a catastrophic collision nearly 500 million years into the Earth's history. NASA confirmed many details of this story through the Apollo missions, through the samples of moon rock brought back by the astronauts, which showed chemical similarities to Earth's crust, consistent with a common origin. Apollo 11, in July 1969, was the mission that first placed human beings on the moon. Neil Armstrong and Buzz Aldrin walked on the lunar surface, while Michael Collins orbited above. Armstrong's words, "One small step for man, one giant leap for mankind," are known to virtually everyone on Earth. But beyond the words and the flags and the footprints, the Apollo program gave us something far more profound than a successful mission. It gave us a photograph. Taken on Christmas Eve, 1968, by Apollo 8 astronaut William Anders as the spacecraft orbited the moon. A photograph of Earth rising above the lunar horizon, a fragile blue marble floating in the vast black of space. Earthrise. That image, arguably more than any single scientific discovery, changed the way humanity thought about itself. Because when you see the Earth from the moon, you see how small it is, how alone, how beautiful, and how surrounded by emptiness. The borders between nations are invisible from there. The divisions, the arguments, the endless noise of human conflict, all of it disappears, and what remains is this: a small, quiet, living world wrapped in a thin blue layer of air, rotating slowly in the dark. Every human being who has ever lived, every war ever fought, every love ever felt, every book ever written, every dream ever dreamed, all of it happened on that blue dot. Carl Sagan called it the pale blue dot, in his famous reflection on a 1990 photograph taken by the Voyager 1 spacecraft from a distance of about 6 billion kilometers. In that image, Earth is a tiny, almost invisible speck of light, less than a pixel wide, suspended in a ray of scattered sunlight. It is, in its way, the most humbling photograph ever taken. And Voyager 1 itself is one of NASA's most extraordinary achievements. Launched in 1977, it has been traveling continuously for nearly 5 decades and is now the most distant human-made object ever created. More than 23 billion kilometers from the Sun in interstellar space, beyond the edge of the heliosphere, in the ocean between the stars. It still sends signals back to Earth, though by the time those signals arrive, traveling at the speed of light, they are so faint that receiving them requires some of the most sensitive instruments ever built. Somewhere out there, moving through the dark between the stars, is a golden record, attached to Voyager 1 and its twin, Voyager 2, containing sounds and images of Earth, music and greetings in dozens of languages, the sound of wind, rain, and ocean waves, the cry of a newborn, a piece of Bach, a piece of Beethoven, a piece of Chuck Berry, a message in a bottle, cast into the interstellar ocean, addressed to anyone or anything that might one day find it. Let that land softly. A message carried on a spacecraft moving at 17 kilometers per second, drifting through the silence between the stars. It will take about 40,000 years before Voyager 1 passes close to another star system. The record may never be found, or it may be found by something beyond our imagination. We sent it anyway, because that is what we do. We reach outward. We say hello into the dark. We hope. Let your breathing slow further now. Let your muscles soften and your mind begin to loosen its grip on the day. There is nowhere to be right now. There is only this: a quiet voice, a dark sky, and the soft, patient universe unfolding around you like petals opening in the dark. Let's move now toward the planets, because some of the most beautiful and surprising discoveries NASA has made involve the worlds closest to us. Our 8 siblings in orbit around the Sun, each one strange and different, each one full of stories. Mercury, the smallest planet and the closest to the Sun, is a world of extremes. With almost no atmosphere to retain heat, its surface swings between 430 degrees Celsius in the sunlight and minus 180 degrees in the dark. NASA's Messenger spacecraft orbited Mercury from 2011 to 2015 and revealed something unexpected. At the planet's poles, in the permanent shadows of deep craters, there is ice, water ice, protected from the sun's heat by the very craters that shadow it. Even Mercury, that scorched rock closest to the Sun, has a hidden store of frozen water. Venus, the second planet, is often called Earth's twin because of its similar size and mass. But it is a twin in the way a nightmare is the twin of a dream. Venus has a thick, dense atmosphere of carbon dioxide and sulfuric acid clouds, creating a runaway greenhouse effect so extreme that its surface temperature is around 465 degrees Celsius, hot enough to melt lead, even though it is farther from the Sun than Mercury. The atmospheric pressure at Venus's surface is 90 times that of Earth. Landing a spacecraft there is one of the most difficult engineering challenges ever attempted. The Soviet Venera probes in the 1970s and 80s managed to land on Venus and send back data and images before being destroyed by the heat and pressure, typically within about an hour. Those images, grainy, orange-tinted photographs of a rocky, alien surface under an overcast sky, are among the strangest things humanity has ever seen. A world right next door to us, and yet as foreign as a dream from another mind. Mars has captivated human imagination for centuries, and NASA has explored it more extensively than any other planet. The Viking landers in the 1970s were the first spacecraft to successfully land on Mars and send back color photographs. The Pathfinder mission in 1997 deployed the first Mars rover, a small six-wheeled vehicle named Sojourner, about the size of a microwave oven, that trundled around the Martian surface and sent back images of red rock and dust and a pale butterscotch sky. Then came Spirit and Opportunity in 2004. Twin rovers, each the size of a golf cart, designed for a 90-day mission. Spirit operated for 6 years. Opportunity operated for nearly 15, covering more than 45 kilometers of the Martian surface and making discoveries that fundamentally changed our understanding of the planet. Opportunity found evidence that liquid water once flowed on Mars. Not just ice, not just vapor, but liquid water, standing in pools or running in rivers, perhaps billions of years ago. The rover found mineral deposits that form only in the presence of liquid water, layered rocks that tell the story of ancient lakes and streams. Mars, that cold, dry, dusty world, was once warmer and wetter. It may once have had oceans. And where there was liquid water, there may once have been life. This is one of NASA's most important ongoing questions. The Mars Science Laboratory mission, the Curiosity rover, which has been operating in Gale Crater since 2012, has confirmed that Mars once had the chemical ingredients necessary for life as we know it: carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, and an energy source. Curiosity found organic molecules in ancient rock. It found seasonal fluctuations in atmospheric methane, a gas that on Earth is primarily produced by biological processes, though it can also have geological origins. Perseverance, NASA's most recent Mars rover, landed in Jezero Crater in 2021, a region believed to be an ancient river delta, and has been collecting rock samples that may one day be returned to Earth for analysis. Among its remarkable achievements, the first powered flight on another planet. The Ingenuity helicopter, a small, lightweight aircraft about the size of a tissue box, lifted off from the Martian surface in April 2021 and completed a 39-second flight. It was the first time a powered aircraft had flown in the atmosphere of another world. The Wright brothers' first flight at Kitty Hawk in 1903 lasted 12 seconds. Ingenuity flew for 39 seconds on another planet 117 years later. Progress moves in spirals. It returns to familiar shapes, but always from a higher place. Let's drift further out now, into the deeper solar system. Past the asteroid belt, a ring of rocky debris between Mars and Jupiter, the remnants of material that never quite coalesced into a planet, and into the realm of the giants. Jupiter, the largest planet in the solar system, so large that all the other planets could fit inside it with room to spare. Its famous Great Red Spot is a storm that has been raging continuously for at least 350 years, possibly much longer. A hurricane so large that 2 or 3 Earths could fit within its swirling bands of cloud. And yet, for all its violence and scale, there is something deeply beautiful about Jupiter when you see the full-color images NASA's Juno spacecraft has sent back. Swirling pastels of cream and orange and burgundy, complex cloud patterns that look almost alive, like watercolors dropped into water and slowly spreading. Juno has been orbiting Jupiter since 2016, diving closer to the planet than any spacecraft before it. And it has revealed that Jupiter's interior is far more complex than expected. The planet doesn't have a simple rocky core surrounded by gas, as older models suggested. Instead, it appears to have a diffuse, extended core of mixed rock and metallic hydrogen, blurring smoothly into the surrounding material. Jupiter is strange, even by Jupiter's standards. But it is Jupiter's moons that may hold the most profound secret in the solar system. Europa, a moon slightly smaller than Earth's moon, covered in a smooth, cracked shell of ice. Underneath that ice, kept liquid by the tidal forces of Jupiter's enormous gravity flexing the moon's interior, is an ocean of liquid water, not a small one. Europa's ocean is estimated to contain roughly twice as much liquid water as all of Earth's oceans combined. And where there is liquid water, there may be life. NASA has been studying Europa for decades, and the Europa Clipper spacecraft, launched in 2024, is now en route to perform dozens of close flybys of the moon, studying its ice shell, its ocean, its magnetic field, and its surface chemistry. Scientists have detected water vapor plumes erupting from Europa's surface, venting material from the ocean beneath directly into space. Future missions may be able to sample those plumes and analyze them for biosignatures, chemical signs of biological processes. Europa is not the only ocean moon in the solar system. Enceladus, a small moon of Saturn, also has a subsurface ocean, and its plumes, discovered by NASA's Cassini spacecraft, contain water vapor, ice particles, and organic compounds including hydrogen, carbon dioxide, and methane. Cassini actually flew directly through those plumes multiple times, tasting the chemistry of an alien ocean without ever having to land. Titan, Saturn's largest moon, is even stranger and more wonderful. It is the only moon in the solar system with a thick atmosphere, and the only world other than Earth known to have stable liquid on its surface. But not water, liquid methane and ethane. Titan has rivers, lakes, and seas of liquid methane, dunes of organic sand, and a weather cycle of methane rain and evaporation. It is an Earth-like world in its geography, but so cold, around -179 degrees Celsius, that the chemistry is entirely alien. Cassini orbited Saturn for 13 years and gave us some of the most beautiful images ever captured in planetary science. The rings of Saturn photographed up close, gossamer and precise. The hexagonal storm at Saturn's North Pole, a geometric weather system unlike anything on Earth. The dark, organic plains and bright, icy mountains of Titan mapped by radar. And Enceladus, backlit by the sun, its plumes of water ice spraying into space like a tiny, cold geyser in the dark. Saturn's rings are one of the solar system's greatest spectacles. They are made of ice and rock, ranging in size from grains smaller than a snowflake to boulders meters across, and they extend nearly 300,000 kilometers from the planet, almost the distance from Earth to the Moon, and yet are, in most places, less than a kilometer thick. If you scaled Saturn's rings down to the thickness of a sheet of paper, they would extend more than a kilometer outward. They are enormous and impossibly thin, a great flat disk of ice catching the sunlight around a pale golden giant. And they are not permanent. Saturn's rings are slowly being pulled into the planet by gravity, a process called ring rain. In perhaps 100 million years, the rings as we know them will be gone. We live at a special time in the solar system's history, a time when Saturn's rings exist in their current spectacular form. Another coincidence in a universe full of them. Let your eyelids grow a little heavier now. There's no rush to follow every word, no test to pass, no detail to remember. You're just drifting through the solar system on a quiet current of thought and starlight, and the universe is very gently rocking you towards sleep. Let's move now to one of the most important revolutions in astronomy, one that NASA and its partner organizations helped bring about, and that changed the way we understand the nature of the cosmos itself. In the late 1990s, astronomers were studying a type of stellar explosion called a Type 1a supernova. These explosions are useful because they always produce approximately the same amount of light, making them what astronomers call standard candles, reliable reference points for measuring vast distances in the universe. By comparing how bright these supernovae appear to us against how bright they should be, you can calculate how far away they are. What the astronomers found was astonishing and disturbing and ultimately wonderful. The supernova were dimmer than they should have been, not by a little, by enough to suggest that they were farther away than the expansion rate of the universe predicted. The universe wasn't just expanding, it was expanding faster and faster over time. This was the opposite of what everyone expected. Gravity should have been slowing the expansion down. Instead, the expansion was accelerating. Something was pushing the galaxies apart, faster with every passing moment. That something was named dark energy, and it makes up approximately 68% of the total energy content of the universe. We don't know what dark energy is. We can measure its effects. We can see the acceleration it causes. But its fundamental nature, whether it is a property of space itself, a new field permeating the cosmos, or something else entirely, remains one of the deepest open questions in all of science. The discovery of dark energy won the Nobel Prize in Physics in 2011. It was, in many ways, the universe reminding us that we are still at the very beginning of understanding it. We live in a universe that is 95% invisible and mysterious, accelerating apart in all directions, on a planet orbiting an ordinary star in one of 2 trillion galaxies, made of atoms forged in stellar explosions billions of years ago. And somehow, we are here, conscious, curious, looking up. NASA's Wilkinson Microwave Anisotropy Probe, WMAP, launched in 2001 and spent 9 years mapping the cosmic microwave background radiation in extraordinary detail, refining our measurements of the universe's age, composition, and geometry. It confirmed that the universe is approximately 13.8 billion years old. It measured that the universe is geometrically flat, meaning that parallel lines extended through space would remain parallel forever, rather than curving together or apart. And it provided the most precise map ever made of the universe's earliest moments. Then came Planck, a European Space Agency mission that extended WMAP's work with even greater precision, and the James Webb Space Telescope, launched on Christmas Day 2021, which has already, in its relatively short operational life, transformed our understanding of the early universe. The James Webb Space Telescope is NASA's successor to Hubble, and in many ways, it is the most extraordinary scientific instrument ever built. While Hubble observes primarily in visible and ultraviolet light, Webb observes in infrared, wavelengths of light invisible to human eyes, but perfectly suited for seeing through the clouds of dust that obscure star-forming regions, and for detecting the light of the most ancient and distant galaxies, whose visible light has been red-shifted into the infrared by billions of years of cosmic expansion. Webb's first images, released in July 2022, produced a collective gasp from much of humanity. Webb's first deep field, the deepest, most detailed image of the distant universe ever captured in infrared light, showed thousands of galaxies spanning billions of years of cosmic history in an image so packed with detail, so rich with light and color and depth that it was almost difficult to believe it was real. One image in particular became iconic, a cluster of galaxies so massive that its gravity bends and warps the light of even more distant galaxies behind it, creating curved arcs and smears of light. A phenomenon called gravitational lensing, which Einstein's general relativity predicts, and which Webb captured with breathtaking clarity. Webb has looked at the atmospheres of exoplanets, planets orbiting other stars, and detected the chemical signatures of their atmospheres with a precision never before possible. It has observed the earliest galaxies ever seen, some of them so ancient they formed just a few 100 million years after the Big Bang, and found that they are larger and more complex than models predicted. The early universe, it seems, was forming stars and galaxies faster than we thought. Webb has also captured images of star-forming regions of breathtaking beauty, the cosmic cliffs of the Carina Nebula, a vast panorama of gas and dust where new stars are being born, rendered in glowing oranges and blues and the deep purple-black of the surrounding space. It looks like a landscape, like mountains and valleys, except that those mountains are 3 light-years tall, and the valleys are carved by the radiation of newborn stars, exoplanets. Let's spend some time here, because this is one of the most extraordinary chapters in the story of NASA's discoveries, and one of the most profoundly human. The question of whether other worlds orbit other stars is ancient. Giordano Bruno wrote about it in the 16th century and was burned at the stake, in part for suggesting it. For most of human history, it was philosophy, not science. We had no way to know. Then, in the 1990s, we learned to know. NASA's Kepler Space Telescope, launched in 2009, was designed to do one thing: stare at a single patch of the sky containing about 150,000 stars, and look for the tiny periodic dimming of starlight that occurs when a planet passes in front of its star, a transit. The dimming is tiny, typically much less than 1% of the star's total brightness, and detecting it requires extraordinary precision. Kepler detected it, over and over. By the time the mission ended in 2018, Kepler had discovered more than 2,600 confirmed exoplanets, with thousands more candidates awaiting confirmation. It revealed that planets are extraordinarily common in the Milky Way, that most stars have planets, and that many of those planets are rocky, roughly Earth-sized worlds that might, in the right conditions, support liquid water on their surfaces. Kepler found planets orbiting in the habitable zone, the range of distances from a star where temperatures might allow liquid water, of stars throughout our galaxy. It found planets orbiting two stars at once, like the fictional Tatooine of Star Wars. It found super-Earths and hot Neptunes and water worlds and lava planets and objects so strange they don't fit neatly into any category. And TESS, the Transiting Exoplanet Survey satellite, launched in 2018 as Kepler's successor, has continued the work, surveying nearly the entire sky and discovering thousands more planets, including many around the nearest, brightest stars, the ones we know best and can study most easily. We now know of more than 5,000 confirmed exoplanets, with estimates suggesting that our galaxy alone contains hundreds of billions of them. The universe is not a barren place of stone and gas and darkness. It is filled with worlds, more worlds than we can count, more worlds than we have names for, more worlds than all the grains of sand on all the beaches of the earth. Are any of them inhabited? We don't know. That is the honest answer, and it is one of the most important things humanity will ever come to know. The search for life beyond Earth, astrobiology, is one of NASA's central missions. SETI, the search for extraterrestrial intelligence, has been scanning the sky for radio signals from other civilizations for decades, so far in silence. But that silence doesn't mean absence. The universe is 13.8 billion years old. Life on Earth appeared about 3.8 billion years ago. Intelligent life, capable of technology, appeared only a few 100,000 years ago. We are cosmically new. If other intelligent life exists, it may be very far from us, or using forms of communication we haven't yet imagined, or separated from us by gulfs of time that make meeting essentially impossible. But microbial life, simple organisms, bacteria and their equivalents, may be another matter entirely. The conditions required for simple life are far less demanding than the conditions required for intelligence. And those conditions, as we've seen, exist in many places in our solar system. Europa, Enceladus, Titan, even Mars may have harbored or may still harbor simple life. If we were to find even a single bacterium in the ocean of Europa, it would be the most important discovery in human history. It would mean that life, wherever the conditions permit, tends to arise. It would mean the universe is not a sterile place. It would mean we are not alone. Let that idea rest in you gently now, like a small light in the dark. You don't have to decide anything about it. You don't have to draw conclusions. Just let it be there, the possibility of it, warm and open and full of wonder. Now let's turn for a moment to time. Because time, and the strange ways it behaves according to the physics that NASA and other scientific institutions have helped confirm, is one of the most mysterious and beautiful aspects of the universe. Albert Einstein showed us, in the early 20th century, that time is not the fixed universal clock we might instinctively imagine. Time is relative. It flows at different rates depending on how fast you are moving and how strong the gravitational field around you is. The faster you move, the slower time passes for you relative to a stationary observer. The stronger the gravity you're in, the slower time passes for you relative to someone in weaker gravity. This isn't philosophy or metaphor. It is measurable fact. The GPS satellites orbiting Earth must correct their clocks constantly to account for the effects of both special and general relativity. Without those corrections, GPS navigation would accumulate errors of several kilometers per day. Relativity is built into the technology in your pocket. Time passes more slowly in a stronger gravitational field. If you stood at the base of a tall mountain, you would age very slightly more slowly than someone standing at the peak. The difference is immeasurably tiny in everyday life, but over long enough timescales it becomes significant. Near a black hole, where gravity is extreme, time slows to a crawl. At the event horizon itself, time, from an outside perspective, stops entirely. And at the beginning of the universe, in the earliest fractions of a second, the nature of time was different from anything we experience now. Some physicists suggest that time itself may have no beginning in the way we intuitively imagine, that the concept of before the Big Bang is as meaningless as the concept of north of the North Pole. There is no north of the North Pole because north is defined in relation to it. There may be no before the Big Bang because time is defined in relation to the universe's existence. These are the edges of human understanding, places where the maps run out and there is only the open, uncharted dark. And yet, even here, at the very edge, there is something deeply comforting rather than frightening. The knowledge that the universe is so much larger and stranger than we are, and that our curiosity, our reaching toward it, is itself one of the most beautiful things in nature. The universe does not know we are here. Stars don't care about us. Black holes have no awareness of our existence, and yet we are here, aware of them, aware of the universe, capable of measuring it and wondering about it, and feeling moved by it. In all the observable universe, as far as we know, only here, on this small blue world, is there anything that has looked up at the stars and felt wonder. That too is a discovery. Perhaps the most important one. Let your body grow heavier now. Let the thoughts slow and soften, like the light just before dawn, when the sky is between darkness and color and everything is very still. You've traveled a long way tonight, from the Big Bang to the first stars, from the Apollo missions to the rings of Saturn, from the ocean of Europa to the pale blue dot, from the first black hole photograph to the fires of the Carina Nebula. And there is still so much more. Let's think for a moment about nebulae, because they are among the most visually stunning objects in the cosmos, and there is something profoundly peaceful about them. A nebula is, at its most basic, a cloud of gas and dust in space. But the varieties are extraordinary. Emission nebulae glow with their own light, lit from within by the radiation of hot young stars. Reflection nebulae shine with borrowed light, scattering and reflecting the light of nearby stars in soft blues and silvers. Dark nebulae are clouds dense enough to block the light of stars behind them. Vast, dark shapes against the glowing background of the sky. And then there are planetary nebulae, among the most beautiful objects in the universe and among NASA's most frequently photographed subjects. A planetary nebula forms when a sun-like star reaches the end of its long life and gently expels its outer layers into space, leaving behind a small, hot core called a white dwarf. The expelled gas glows in the ultraviolet radiation of the dying star, forming intricate, delicate structures of light, rings and spheres, and bipolar jets and complex geometries that look almost deliberate, almost designed. The Helix Nebula, photographed by Hubble, is sometimes called the Eye of God. A blue-green iris of glowing gas surrounding the pale point of a white dwarf staring back at you across 650 light-years of space. The Ring Nebula is a perfect, almost circular ring of blue and green light with a white dwarf at its center. The Butterfly Nebula has two great wings of glowing gas, symmetric and luminous, spreading across several light-years. These are the remains of stars. This is what our Sun will become in about 5 billion years. Our Sun will exhaust its hydrogen fuel, expand into a red giant large enough to engulf Mercury, Venus, and possibly Earth, and then collapse gently inward, expelling its outer layers in a nebula of extraordinary beauty, and leaving behind a white dwarf, a ball of carbon and oxygen no larger than the Earth, slowly cooling over billions of years until it fades to darkness. Whatever was here then, whatever worlds or beings have evolved over the next 5 billion years, will be bathed in that expanding cloud of light. The death of our star will be beautiful, and its matter, scattered into space, will eventually become part of new clouds, new stars, new planets, new possibilities. The cycle continues. It has always continued. It will continue for as long as the universe exists. How long is that? A very long time. The universe will likely continue expanding for trillions upon trillions of years. The last stars won't burn out for perhaps 100 trillion years, 100,000 times the current age of the universe. And after that, gradually, over unimaginable timescales, even black holes will evaporate through a quantum process called Hawking radiation, discovered theoretically by Stephen Hawking in 1974. The universe will grow increasingly cold, dark, and empty. A final state called heat death, maximum entropy, minimum structure. But that is so far away, it is essentially beyond the ability of the human mind to truly imagine. On the scale of time we live in, the scale of human lives, of civilizations, of even the entire history of life on Earth, the universe is in its youth. The stars are still burning. The galaxies are still full of light and motion. The nebulae are still forming stars. We are here at a lucky time, in the middle of something vast and alive. Let your breathing slow down a little more. Let each breath out carry a little of the day's tension with it, gently released into the dark. There is something very right about this. The way breathing connects you to everything. The air you're breathing right now has been breathed by billions of organisms over millions of years. Some of its atoms may once have drifted through a nebula, been part of a dying star's last breath, fallen through space for billions of years, arrived with the early Earth, cycled through ancient oceans and through the lungs of creatures that no longer exist, and found their way tonight to you. You are connected to everything, not metaphorically, literally. Through the atoms, through the elements, through the long chain of stellar births and deaths, and the vast recycling of matter that the universe has been practicing since the very beginning. You are a local concentration of ancient energy, briefly organized into a beautiful and improbable form, aware of its own existence and the existence of everything around it. There's something deeply restful in that, if you let it be. The pressure of being separate, of being a self that must manage and protect and perform. It loosens a little when you remember that you are, at the deepest level, continuous with the universe, not isolated, not alone, part of something that has no edges and no end. Let's return for a moment to NASA's most recent and ongoing discoveries, because the story isn't finished. It never is. The James Webb Space Telescope continues to operate, And with each new image and spectrum it sends back, our picture of the universe sharpens and surprises us. Webb has begun detecting the atmospheres of planets in other solar systems, looking for signs of water vapor, carbon dioxide, methane, and potentially the biosignatures of life. It has found carbon dioxide in the atmosphere of exoplanet WASP-39b, the first time a carbon compound has been directly detected in the atmosphere of a planet outside our solar system. The Nancy Grace Roman Space Telescope, scheduled to launch in the late 2020s, will survey the sky with a field of view 100 times wider than Hubble's, studying dark energy, dark matter, and exoplanets in unprecedented breadth. It will be, in some ways, a telescope designed not to look at specific objects in detail, but to take stock of the universe, to map and measure it at a scale we've never achieved before. NASA's Artemis program is working to return humans to the Moon, this time with the goal of establishing a sustainable presence, a lunar gateway station in orbit, eventual habitats on the surface, and the development of technologies needed to eventually carry human beings to Mars. We may, within the lifetimes of people alive today, send the first humans to walk on another planet. The Parker Solar Probe has been diving closer to the Sun than any spacecraft in history, dipping into the solar corona, the outermost layer of the Sun's atmosphere, and enduring temperatures of nearly 1,400 degrees Celsius behind its heat shield, measuring the solar wind, the magnetic field, and the plasma physics of our nearest star up close. In 2021, it became the first spacecraft to physically enter the Sun's atmosphere, touching the corona and passing through it. OSIRIS-REx collected samples from the asteroid Bennu and returned them to Earth in September 2023, the first asteroid sample return mission in NASA history. The analysis of those samples is ongoing, and they may contain organic compounds from the very earliest period of the solar system. Pristine material that has not changed significantly in 4.5 billion years, a kind of time capsule from before the planets formed. Dragonfly, a rotorcraft lander planned to launch in the late 2020s, will fly through the thick atmosphere of Titan, Saturn's strange methane-soaked moon, exploring its surface chemistry in search of complex organic molecules and prebiotic chemistry. It is, in essence, a mission to a world that may be undergoing in slow motion some of the chemical processes that occurred on early Earth before life appeared. A world with no life, but full of the ingredients for it. And the quiet, patient work continues. Dozens of satellites monitor the Earth itself, its weather, its ice, its oceans, its forests, its atmosphere. NASA studies our own world as carefully as it studies the others, and what those satellites have told us about Earth is as important in its way as anything we've learned about distant galaxies. They have told us that the planet is warming faster than at any point in the last 800,000 years, that ice sheets are melting, that sea levels are rising, that weather patterns are shifting. They have given us the data to understand what we are doing to our home and why it matters. The overview effect, the shift in perspective experienced by astronauts when they see the Earth from space, changes people. Every astronaut who has experienced it describes something similar, a sudden, visceral understanding of how thin and fragile the atmosphere is, how small and interconnected and alone the Earth is, how arbitrary and foolish the boundaries and conflicts that occupies so much of human attention seem from that vantage point. You don't have to go to space to feel a version of that. You can feel it right now if you let yourself. The Earth is spinning beneath you at hundreds of kilometers per hour. It is orbiting the Sun at 30 kilometers per second. The entire solar system is moving through the galaxy. The galaxy is moving through the local cluster. The local cluster is moving through the supercluster. Everything is moving, always, in great sweeping arcs through the expanding universe. And in the middle of all of this, on a spinning rock wrapped in a thin blue blanket of air, you are lying down, breathing slowly, letting your mind drift out toward the stars. That is beautiful. It really is. Let the warmth of your body be the warmth of a star burning quietly. Let your breath be the slow pulse of a nebula, contracting and expanding over millions of years. Let your thoughts, growing quieter now, be like the light of distant galaxies, still traveling, still present, but growing softer with distance, softer and softer, until they are just a warm glow in the dark. There is one more thing I want to share with you before we drift into silence together. Somewhere in the cosmos, there are structures so large they make galaxies look like grains of sand. Galaxy clusters, collections of hundreds or thousands of galaxies bound together by gravity, surrounded by vast halos of hot gas and dark matter. And clusters of clusters form superclusters, and superclusters form the largest structures in the universe, filaments and sheets and walls of galaxies, separated by vast, almost empty regions called cosmic voids. The whole thing, when mapped out, resembles something organic, something like the structure of a brain, or a neural network, or a web spun by a creature of unimaginable scale. Glowing nodes where clusters concentrate, long threads of filament connecting them, dark voids between them, like the silence between thoughts. We call this the cosmic web, and NASA's dark energy surveys and deep field observations have helped map it across billions of light years. It is the largest structure in the universe, and it formed from those tiny fluctuations in the early universe, those almost imperceptibly small variations in density that COBE first mapped, those seeds planted in the first fractions of a second after the Big Bang that grew over 13.8 billion years under the patient pull of gravity into everything. From those seeds, you, from those seeds, all of this. The entire story, every galaxy, every star, every ocean and mountain and creature and thought grew from an almost infinitely small irregularity in the plasma of the newborn universe. There is a line from that beginning to this moment, unbroken. A chain of cause and effect, of energy transforming and matter rearranging, of increasing complexity and improbable beauty that connects the first light of the universe to the light that is even now reaching your closed eyelids. The warmth that is even now moving through your lungs, the quiet awareness that is even now, softly and gently, letting go of the day. You are part of this story. You have always been part of it. You were there, in a sense, at the beginning, in the hydrogen that would become stars, in the stars that would become your atoms, in the atoms that would become you. And when this chapter ends, the story will continue in ways we cannot imagine, carrying forward the matter and energy that once made you into new configurations, new forms, new wonders. That is not a reason for sadness. It is, if you hold it just right, a reason for something that feels very much like peace. The universe is very old. It has seen countless suns rise and fall. It has watched galaxies collide and merge and separate over billions of years. It holds all of this without effort, without judgment, with a kind of vast and impersonal patience that is, in its way, the closest thing the cosmos has to kindness. You are held by that, right now, in this moment. Whatever the day was, whatever tomorrow brings, whatever the world looks like outside your window tonight, you are held by the universe, by the same gravity that holds the stars in their orbits and the planets in their paths and the galaxies in their ancient spiraling dance. Let yourself be held. Let your thoughts slow to a drift. Let your body grow heavy and warm. Let the distance between this voice and the nearest star, 4 light years, an immensity, shrink to something that feels in this moment almost intimate. You and the stars, breathing in the dark together. You, who are made of stars, resting among them. The universe has no bedtime. It doesn't sleep, but you do. And sleep is one of the most beautiful things that exists in the observable cosmos. A nightly journey inward, a dissolution of the self into something deeper and quieter, a small rehearsal of the vast silence between the stars. Sleep is, in its way, a kind of space travel. When you close your eyes and let go, you leave the ordinary world behind. You move through landscapes that follow their own laws, their own gravity, their own sense of time. Dreams are the mind's own universe, full of strange planets and impossible skies, and faces that belong to people you've never met and somehow know completely. Science doesn't fully understand dreaming, even now. It remains one of the last great mysteries of the human interior, as dark energy is one of the last great mysteries of the exterior cosmos. We are surrounded by mystery from the inside out, and that is exactly as it should be. NASA has given us so much. It has given us photographs of our own planet from space, that fragile blue marble, that pale blue dot. It has given us the knowledge that we live in an expanding universe born from a single ancient event of almost incomprehensible power. It has given us the faces of other worlds, the red deserts of Mars, the golden clouds of Titan, the icy geysers of Enceladus, the storm-wrapped bulk of Jupiter. It has given us the first image of a black hole, the deepest photographs of the universe ever taken, the first powered flight on another planet. But perhaps the greatest thing it has given us is perspective. The quiet, humbling, ultimately liberating knowledge that we are small, and that being small in a universe this large, this old, this beautiful, is not something to mourn. It is something to marvel at. We are small the way a single note is small compared to a symphony, essential, resonant, part of something far greater than itself. You are a note in the symphony of the universe, a brief, bright, irreplaceable note. And now, as the symphony plays on around you, stars turning, galaxies drifting, nebulae slowly brightening with the light of newborn suns, it is time for your note to rest, to go quiet for a while, to let the music continue without you, knowing that when morning comes, you will return to it refreshed, and the universe will still be there, patient and vast and full of light. Let your eyes stay closed. Let your breathing find its own rhythm, slow and deep and easy. Let any last thoughts float upward like embers from a dying fire, briefly bright, then gone, carried away on a warm current of air into the dark. There is nothing you need to do now, nothing you need to understand or remember or resolve. You have traveled far tonight, through the birth of the universe and the death of stars, through the oceans of distant moons and the silence between galaxies, through 13.8 billion years of light and matter and time. You have traveled far, and now it is time to rest. Somewhere, right now, the Voyager 1 spacecraft is moving through interstellar space, further from home than any human-made object has ever been, carrying its golden record of music and voices and the sound of rain, drifting in the dark between the stars. It is moving slowly relative to the scale of the cosmos. It will travel for 40,000 years before it comes close to another star. And in a way, you are a little like that. Moving through the dark, carrying within you something precious, the experiences and feelings and memories of a life, drifting gently forward into the unknown. But tonight, you are not moving. Tonight, you are still, held in place by gravity and warmth and the soft weight of sleep descending like the first snow of winter, slow and silent and covering everything. The universe is 13.8 billion years old. It has been here a very long time, and it will be here when you wake. The stars will still be burning. The galaxies will still be turning. The James Webb Space Telescope will still be staring into the deep, gathering ancient light. Mars will still be red and cold and waiting. Europa's ocean will still be dark and still beneath its shell of ice. Saturn's rings will still be catching the sunlight, thin as paper, wide as the distance from the Earth to the Moon. All of it will be there, and you will wake into a world full of it, full of the ordinary miracle of air and light, and the weight of your own body, the smell of morning, the particular quality of the first few moments when the mind returns from wherever it went in the night. But that is for later. For now, let go, completely and without effort, the way a cloud lets go of its shape and becomes simply sky, the way a wave lets go of its form and becomes simply ocean, the way the day lets go of its noise and becomes simply night. You are safe, you are held, you are home. Sleep now among the stars. Good night, dear traveler. Good night from dreams of gravity. May your sleep be deep and soft. May your dreams be wide and full of light. And may you wake tomorrow with the quiet, lasting feeling that you are, in the most profound and literal sense, a child of the universe, welcome in it, woven into it, as real and as necessary as the stars themselves. Good night.